The following diagram shows a line segment AB with length 2 centimeters. The line is divided into an infinite number of line segments. The diagram shows the first 3 segments. The lengths of the line segments are p, p squared, p cubed, and so on, where p is greater than 0 and less than 1, shows that p is equal to 2/3. So we can see that each next length is the previous multiplied by p. You can see that p squared is p times p, p cubed is p squared times p. So it's what? It's geometric sequence. And since there are infinitely many line segments, the total length, it's what? It's just the sum of an infinite geometric sequence, and formula is given in a data booklet, and it says that it's what? U1 divided by 1 minus ratio. Ratio, it's p, u1 is also p, it's the first term of this geometric sequence, and sum to infinity is the total length. So we get that 2 is u1, it's p, divided by 1 minus p, then cross multiplication or multiplying both sides by 1 minus p, we get that 2 multiplied by 1 minus p is equal to p, 2 minus 2p is p, 2 is 3p, hence p is 2/3 as required. The next. The following diagram shows a line segment CD with length b centimeters, where b is greater than 1, squares with side lengths k, k squared, and k cubed, where k is greater than 0 and less than 1, are drawn along line segment CD. This process is carried on infinitely. The diagram shows the first 3 squares. The total sum of the areas of all the squares is 9/16. Find the value of b. So first of all, b is the total length, and notice that k it's the length of the side of the first, k squared of the second, k cubed of the third square, and so on. So absolutely similarly, if we consider sum to infinity, and total length, it's sum to infinity of all lengths, so we can say that b is u1, it's k, divided by 1 minus ratio, and it's clear that ratio is also k. So if you know k, you can calculate the required value of b. But how to find k? It is also given that the sum of all squares, so it's the sum of areas up to infinity. So let's consider the values of areas. Since it's a square, and if side length is k, so area is k squared. And this area is what? K squared and squared, so k to the power of 4, and this is k to the power of 6, and we can see that the first term is k squared, and common ratio it's also k squared, and total area or the sum of all areas, it's 9/16. It's sum to infinity. The first term is the first area, which is k squared, divided by 1 minus ratio. Ratio is also k squared. Hence we need to solve for k and then calculate the value of b. So again, cross multiplication, 9 1 minus k squared, which is 9 minus 9k squared, is equal to 16k squared. 9 is 25k squared. K squared is 9/25. K is in general it's plus minus square root, but since k it's a length, it cannot be negative, so k is positive square root of 9/25, which is 3/5. And then b becomes k 3/5 divided by 1 minus 3/5. 3/5 divided by 1 is 5/5, so it's 5 minus 3, 2/5, and it becomes 3/2. So the required value of b is 3/2. And that's all for this question.